The more we study the cosmos, the clearer it becomes. Our universe is extraordinarily well suited for life. But what if it's not the only one? Welcome to Infinity Beyond. In this segment, we explore a breathtaking idea at the edge of science: the multiverse, a concept that could explain why our universe works the way it does, and why we're here to observe it at all. Let's start with a question that has baffled physicists for decades. Why is the vacuum energy of our universe so incredibly small, but not zero? As we discussed in the previous segment, theoretical calculations of vacuum energy, based on quantum field theory, predict a value that is 120 orders of magnitude larger than what we actually observe. This is the worst mismatch in physics. By all rights, such an enormous energy should have blown the universe apart before galaxies, stars, or atoms could ever form. And yet, here we are. So why is the vacuum energy, the fuel behind dark energy and cosmic acceleration, just low enough to allow structure to form, but still non-zero? This puzzle has led many scientists to a radical possibility. We live in just one universe among many, a single bubble in an endless cosmic foam. In this multiverse scenario, every universe in this vast ensemble has different physical constants, different values of gravity, electromagnetism, matter content, or vacuum energy. Some universes might expand too fast for galaxies to form. Others might collapse immediately. In most, life would be impossible. But in a rare few, like ours, the constants are just right. And that's the one we find ourselves in. This explanation relies on something called the anthropic principle, the idea that we observe a life-permitting universe because only such a universe allows observers like us to exist. It's a powerful argument, but also a controversial one. Critics say that invoking a multiverse pushes the problem out of science and into speculation. After all, if other universes are unobservable, how can we ever test the idea? Can something be scientific if it can't be falsified? Proponents argue that it's not so different from other accepted ideas, like quantum mechanics or black holes, which were once abstract and unprovable, but gained credibility through indirect evidence. And there's more. The multiverse concept doesn't just arise from desperation. It's a natural consequence of some of our most successful theories. For example, inflationary cosmology, the theory that the early universe underwent an exponential burst of expansion, predicts that different regions of space could stop inflating at different times, creating bubble universes with different properties. This is called eternal inflation, and it suggests a constantly expanding background universe, spawning countless pocket universes, each with its own distinct laws. Similarly, string theory, our best candidate for a theory of everything, allows for a vast landscape of possible solutions, 10 to 500 different configurations, each representing a different vacuum state or universe. With so many possibilities, it's statistically inevitable that some universes will have the right conditions for life. We may have simply won the cosmic lottery, but if the multiverse is real, is there any way to detect it? That's the million-dollar question. Some scientists have proposed looking for collisions between bubble universes, cosmic scars that might be imprinted on the cosmic microwave background. Others look to gravitational waves or subtle anomalies in the expansion rate of space. So far, no conclusive evidence has been found, but the search continues. Meanwhile, other theorists propose dynamical cancellation mechanisms, ideas that don't require a multiverse, but instead suggest that some unknown physics adjusts the vacuum energy over time, like a cosmic thermostat. In these models, the vacuum energy relaxes to a small value through unknown interactions. This would help solve the vacuum catastrophe without invoking other universes. Another class of ideas involves modifying gravity itself. Maybe general relativity, Einstein's masterpiece, needs to be extended to explain the accelerated expansion. Perhaps the structure of space-time bends in ways we haven't yet discovered, or includes extra dimensions that dilute or absorb vacuum energy. These theories are bold and unproven, but they aim to restore a predictive explanation to the problem of fine-tuning. And in the end, that's what science is all about: seeking models that explain what we observe, that make testable predictions, and that deepen our understanding of reality. Whether the answer lies in an infinite multiverse, hidden dimensions, or undiscovered forces, one thing is clear: the vacuum is not empty, the constants are not arbitrary, and the structure of our universe demands an explanation. It may be that we live in a special pocket of a much larger reality, or it may be that our theories are incomplete, waiting for a future breakthrough. Until then, we continue the search. And in that search, we don't just explore the universe. We explore the nature of existence itself.